Hello and welcome back. So in the last video, we discussed function templates. So in this video, I'm going to introduce the concept of class templates. So a template, like I said in the previous video, is nothing but a blueprint. And we have something similar when we talk about classes as well. So you can always define a blueprint for a class, or to use the C++ terminology, a template for a class. So when you try to instantiate the class, all that happens is this template is used as a blueprint and a new class is instantiated. All right. So how do we go about creating a class template? So I've got some code here, and as you can see, this class template definition starts with the keyword template, followed by the less than sign, and then the keyword type name, and the X that you see here is the type, the generic type that we are going to use in our class. And of course, you close with a uh, greater than symbol. And thereafter, you start writing out your class just as you would have done previously. But the only thing that differs is instead of writing a specific data type, you would use the type that you have used in as your template parameter. So X here is a template parameter, and that template parameter is used to declare your class members. So in this case, we've got like a member variable called myval1 and another member variable called myval2. And both these are of type X. Now, if we go further down, this is where the member functions have been uh, declared or defined. So we got the constructor here, and as you can see, it's pretty similar to any constructor that you would write in a C++ class. All that differs is that this constructor takes two parameters, but the type of the parameter is X. So X is nothing but the type that we have used here in a template as a template parameter. So that template parameter is used as one of the parameters for the constructor. And what happens after that? Well, we just go ahead and initialize our member variables as before. So I also have another member function that's declared here. As you can see, the member function has the name add, and of course it returns a type X. So this is just a member function declaration. Let's see how we can define the member function outside the class. And I also have another inline function which is defined within the body of the class. As you can see, it's just a plain and simple display function which actually makes a call to the other member function add. And as you can see, there isn't anything special here. All right, so that's pretty much the definition of declaration of a class template. So as you can see, this is a class template. It's not a class. So what's still remaining to be done is that we need to actually define our member function outside the class. So let's do that now. So once again, we start with the template keyword. We say template, okay, and we say type name, and maybe use that X. And then what's the return type? The return type is of the function add is X, and of course the add function is a member of the adder class. So we say adder, okay, and adder is of type is going to be instantiated with type X. So adder of X, and the add function is a member. So take a look at the syntax again. So we always start a member function definition. When you define a function outside the class, you once again start it with the template keyword, and then you follow it with the parameter list. So you have the same less than sign, the less than and the greater than symbols, and the template parameters defined within them. And we start um, the definition of the function with the function name. And since the function is a member of the class, we still use the same uh, convention of using the member operator to show that the add function is a member of the adder class. The only thing that's different here is the adder class also has to be qualified as taking um, a certain type when it's getting instantiated. And in this case, we know that our type is uh, X. So that's what is done here. The adder class is going to be instantiated using type X, and that type X is going to be used within the add function. So that's what is signified here. All right, so let's see what's it that we need to do within the add function. And you can also see that the add function is returning X. So obviously it's returning um, the result of these two being added. So we add myval2 and myval1. All right. Now all that we need to do is we will say return. Oops. So we say return myval1 plus myval2, and we are done. Okay. And the display function as we can see here is actually just calling the add function. The add function returns the result of the addition. So we should actually, when we call the display function, we should see the result of the addition getting displayed. All right, so let's test our function. So I've got a skeleton here for the main. So now how do we instantiate this class template? It's pretty straightforward. So all that we need to do is adder, and so I want to instantiate it with with integer parameters. So I'm going to instantiate it by supplying the template argument as an int, and uh, let's um, let's call this class maybe adder1. All right, and and obviously it's going to crib because we know our constructor here takes two parameters. So let's supply those two parameters here. So it's two integers. So let's supply 2 and 3. Yes, and we are done with instantiating. So this is how the class template is instantiated, and we are now trying to create an object of this particular class. All right. So in other words, it's nothing but a class template which now has been used to create a class of integers. So this class template is nothing but a plain and simple template. It's not a type. So it's only at this stage that the compiler knows that we are instantiating the class with integer parameters or integer arguments, and the template is now instantiated with the integers. So we have a type which is very specific to the integer that's actually passed here into the template. All right, enough of that detail. So let's get down to business, and let's call adder1 dot what do we need to do? All that we need to do is we call display, and we are done. So adder1 dot display. All right, let me try running this function now. So we should get the result of addition is 5. So let's see what happens. Okay, the result of addition is 5. So that's the result that we expected. Okay, so now let's look at how powerful this concept of class templates is. So now let me create another adder, and this time I'm going to instantiate it with the string type. So I call this adder string, and let me pass two strings, hello, and another string, how are you? All that I need to do now is add a string dot display, and let me run this. So if you look at the second line of output here, it says the result of addition is hello, how are you? So this should give you an idea as to how powerful class templates can be. All that we need to do is define a class template with some generic business logic, and thereafter it's at compile time that the class gets instantiated with specific data types. All right. So you could probably so this saves you a lot of trouble. You do not have to define classes for each and every different data type. So this is a short introduction to class templates. I will leave it to you to investigate and take further into this. Thank you until the next video.